Hello everyone. Today we're going to discuss about a very interesting problems from arrays topic, which is called sort colors. Now this is a very pretty straightforward problem and might have heard at different places. A very interesting algorithm is attached to this problem, which we're going to discuss later. But right now, let's get into the problem. The problem is pretty much straightforward, where you are given three integers 0, 1, 2, each representing a different color. 0 representing red, 1 representing white, and 2 representing blue. Right. So, what we're gonna do is we just want to sort all the zeros together and all the ones together and all the twos together. We just want to keep every color for every color together, right? So in this, as you can see, all the zeros are together, all the ones are together, and all the twos are together. Now this is what the problem states. As you can see, it is pretty much very straightforward problem. Now the second part of the code, we'll look at the constraints. Now the constraint is 3 to 10 raised to power 2. Right, so it's pretty lenient constraints. We can easily write it n of n raised to power 2 or n raised to power 3 time complexity algorithm, but we won't do that because there are number of solutions for which we can do this in O of 1 time and O of n time and O of n space or O of n time and O of 1 space, right? So clearly, just by looking at it, the first solution which comes in a very intuitive solution which comes to the mind is why can't we just do a sort nums dot begin here? Why can't we just use this? Sorry, I wrote the wrong spelling. Nums dot begin and nums dot end, right? So why can't we do just this and be done with it, right? You are right. This will solve the problem and this will get all the test cases passed, but that's not the point of the question. As you can see, it's clearly written here that you must solve this problem without using library sort function. So that means that this thing can't be done. Now, what's the second solution that comes to the mind? Is using hash maps. Oh, okay. So I can just take the value like 0, 1, 2 as the key and number of times they're occurring as the value. Like 0, comma 2, 1, comma 2, 2, comma 2 would be the hash map for this. And I can just replace the values of the nums with the values of the numbers uh, in the hash maps and I can be just done with it, right? This will solve the problem again. But in this case, the time complexity would be O of n and space complexity would be O of n too, right? If you scroll down, you'll see there's a follow-up in which you can read. Could you come up with a one-pass algorithm using constant extra space, right? So we want to use constant extra space here. Now, keep in mind, let's say in earlier case you took a hash map of size right n of size 3, let's say. So in that case, that 3 size of hash map has a what we can say is a constant time complexity, right? But again, at the same time, if you're taking an array of size n, but you're not returning it, then you're taking a space complexity of O of n. But if you take an array of size n and you return it, then the space complexity goes to constant, is that O of 1. In this case, why can't we do that? Because the return type we are given is void. We can't just replace the values of a hash map with the given array and just return it. We have to do it without replacing the values of the given nums and putting into a new array and then returning it. Now we move on to a very interesting algorithm which will help us solve the problem, the required space and time complexity, which is called the Dutch national flag algorithm. What this algorithm do is basically, as you know, a Dutch flag has three colors, right? Similarly, this algorithm states that we need to divide the array in three parts, each divide with the help of three pointers, right? We can name them low, mid, and high. So these three pointer help us to divide the array in three parts, and then with the help of iterating the middle pointer, we can get our possible desired result. How we gonna achieve that? I'll tell you within a minute. But listen, you can also think this in a way that if in a problem you see a three distinct numbers and you have to do some kind of sorting, then this Dutch national flag algorithm should instantly be switched up in your mind, right? Now let's see what are the three conditions that must be achieved, that must be taken care of, or I would rather say there are four conditions which should be taken care of while writing this algorithm. One, why I'm explaining you through the code is because this is a pretty easy code, and this is basically a standard, what I can say, standard code for this algorithm, right? This is pretty much you'll use exact same code you'll use whenever you're applying this algorithm. So, like I said, we'll take three pointers, low, middle, and high, keeping low and middle at the initial index and high at the last index, right? And we want to keep iterating the middle pointer till it crosses the higher pointer, right? As you can see, we'll keep on iterating till middle is less than or equal to high. The moment it crosses the high, we'll just stop it. And the second condition which I've written is n greater than equal to 3. Now you might think, yeah, because we need to sort three colors, so that's why we might need only the elements 3 or greater than 3. No, that's wrong. When I'll run this, I'll show you that it will give an error because I'll tell you the later while it give why it will give an error. But this is a condition which you should not have in your code, right? The first thing which the only condition you need is till the middle pointer crosses the higher pointer. So let's move on to our three conditions. One is that when your middle pointer is at the lowest value, right? Currently we have three integers named 0, 1, 2. So the lowest is 0. It can be any integers in any problem. Like if it can be 5, 6, 7, the lowest integer is 5. Similarly, 20, 20, 30, it would be 10. So when our middle pointer is at the lowest integer, what we want to do, we want to just swap the middle value with the lower value and just increase the point increment both of the pointers, low and middle, right? If our middle pointer comes to the middle value, then we just increment the middle index, right? And the third and the final case is if our middle pointer reaches at the highest value, then we will swap it with the highest with the value of the higher pointer. As you can see, swap it with the higher pointer value and then decrement the higher pointer. So this is pretty much the three conditions which you have to take in mind while writing this code. Now I'll explain you step by step how this condition is helping you in writing this code. I'll just increase this a bit so that it's clear. Uh, right, I hope this should be pretty much clear. So as you can see, I've taken the example from here itself. So initially our lower and middle pointer would be as 0. As you can see, the lower middle pointer should be at 0 and the higher pointer should be at the last index, right? So currently this is our initial array. What we saw is initially the middle pointer is pointing at a value called 2. Now this value is Now this value is the highest value, right? So what we learned, if we get the highest value, then we just swap it with the value at the higher index and just decrement the higher index. So value at the higher index was 0 and value here was 2. So we just swap 2 with 0, right? So it would be 0 and 2 here, and we decrement the higher pointer, right? So now higher pointer would point at 1. Now this is our updated array. One step done. Now our lower pointer is pointing at what? 0, right? The lower pointer is pointing at 0. So, right. So now moving on, we now lower and middle pointer is at 0 here, and higher pointer is pointing at 1. So now what we want to do is we want to just increase, we see our lower pointer is at the lowest index. So we'll just swap it with the value at the lower index with the value at the middle index. Currently both are at the same, so it doesn't matter if we swap them. We just increment both of the pointer, which would take us to which would take us to at here, right? I missed a 0 here. So now our lower and middle pointer are both pointing at index 1, and higher pointer would be at the same position. Now again our middle pointer is pointing at 0, which is the lowest. So again we'll increment both, right? We move both of the pointer one step ahead. Now they're pointing at index 3, and higher pointer is pointing at index 1. Now currently this is what we have till now, right? This is not sorted. Still we have 0, 0, 2, 1, 1, 2. Now at this point, what will happen is we see that our middle pointer is now at value 2, right? And the higher pointer is pointing at 1. So when the middle pointer pointing points at 2, we just swap it with the value at the higher pointer and we'll decrement the higher pointer. So now it will be 1 would be here instead of 2, 2 would be here at one's place and higher pointer would get decremented here. See, now our middle pointer is pointing at 1. In this case, we'll just increment the index of the middle pointer, bit pointer. So it will move from this to this index, and both high and mid pointer would point to 1. Now, as you see, this is not where we should stop. We should keep on going till we reach a pointer, till we crosses the higher pointer, right? So now, again, the middle pointer value is 1, so we'll just simply increment it and it will point to 2. And here at this point, our middle pointer passed the higher one, so we'll stop it here. And as you can see, our array is pretty much sorted 0, 0, 1, 1, and double 2. Now, coming on, I hope you understood the three conditions which are needed to be maintained for Dutch national flag algorithm, and also the uh, iteration loop, which is keep looping till the middle pointer is greater than the higher pointer, right? And now I'll explain why the thing why is equal to is why greater than is used. I mean, why didn't we stop at here? Like, why didn't we stop when the middle pointer and higher pointer is at the same place? Because again, swapping them or moving the pointer might not make sense to you, right? So why an is equal to is being why not an simply is equal to is being stopped here? Why we're crossing it would give an explanation with this example. So I won't explain you this example. I want you to go step by step like I explained you with this example and you'll came to know why we won't stop when both the mid and the high pointer at the same place. Why we have to cross it, right? Why we have to cross the higher pointer. Now the last part of the problem, why this condition is not needed, right? If I submit this code in front of you, you see this code has given me an error, right? Because we need the array to be sorted, right? If our input is 1 and 0, we want it to be 0 and 1, right? We'll just quickly look at how this does national flag algorithm. We don't need it here, but uh, it's good to understand the algorithm once again through this example. So initially, as you know, our low and mid would be here, low comma mid would be here, and our high would be here, right? So here at this point, high would be here. So at this point, middle pointer is pointing at 1. So we'll just increment the middle pointer. Low would still be at 1, and high would be high, and mid would be at what? Uh, 0. Now at this place, since our middle pointer is at 0, right? So we need to swap it with the with the lower pointer, right? With value at the lower pointer. This is the reason why it should be used for two pointers as well. It would be 0. Uh, High would be at 1, and since both of them should be incremented, so low would be here and high would be greater than the value of this array size of the array, and which is obviously greater than the high, so it will stop here and it will return the value required. So if I remove this condition here, it will get passed and we'll get our solution with O of 1 space and O of n time. I hope this solution makes sense to you. If you stuck at any point, just rewatch the video. I know video is a bit long, but it's an important problem. It's one concept which you should keep in mind while dealing with sorting and distinct integers. So just if you like the video, like the explanation, just hit the like button and subscribe. I'll come up with more of these explanation videos later. Thank you.